Hi, my name's Tom, and this is a tutorial for a fireworks effect inside of Unreal Engine 5 Niagara. It's going to be set up in a blueprint, which will allow you to control the amount of fireworks every spawn iteration, as well as giving it some kind of delay in between the fireworks. Let's put this to 5 and 0.1. This should spawn them in rapid succession. Yeah, exactly like this. This is a quick preview of what the Niagara system is going to look like. And this is what the blueprint will look like. Let's start by creating a folder, fireworks_tutorial, and let's add our Niagara system. Let's start with a fountain, because it is already pretty much the setup we need for the rockets. And as for Niagara system_fireworks_tutorial. So this is way too much. We don't need nearly as many as 90. Let's go with 5 for the sake of our preview. And let's give it way more velocity. Let's go with 3000. And let's place it in our world to get some reference. Otherwise it might be a bit difficult only in the preview. Alright, this is working pretty well. So maybe we'll go with a random value between 3000 and 3500. Alright, let's also increase the cone angle a bit so that they spread out a bit more. That looks good to me. Alright, now we want Alright, this already works out for our rockets. You could adjust the velocity, spawn rate to your will, but we're gonna change something up about the spawn rate later on, so maybe wait with that a little bit. Let's call this our rocket emitter, and let's create another minimal emitter, and let's go with the trail. The trail you can either create as a ribbon renderer or a sprite renderer. We're gonna go with the sprite one first, and later on we're gonna create another one for the explosion with a ribbon renderer, so that we covered both of these in the tutorial. Let's start by spawning our emitter from an existing, from other emitter. Let's create fix issue, or let's click fix issue, which will create the sample particle from other emitter, fix again, and let's type in the rocket emitter, enter. Alright, now you can see it's already spawning the trail pretty much along the path of our rocket emitter. This is way too little although. However, this is way too little particles. Let's crank this up to 500, and let's also increase the spawn rate per particle cap. And let's lower the lifetime. Let's see, 0.1. Let's go to random range float. Let's go in between 0.1 and 0.5. Yep. Alright. Let's also lower our spawn rate. Float from curve. Could have done that from the beginning. Let's start with 500. And let's spawn less towards the end. This is just my way of trying to fade it out slightly towards the end. Let's see which one works best. But let's keep working with this. We need to set our size. Let's go with some random values of 10 to 15. And let's scale them out. Oh, particle update, scale color. Let's fade them out with color first. Let's go with a float from curve again. That was a lerp. Float from curve. Always like to go with the smooth versions and change the handle at the end. Alright, this already looks way better. Oh, they are still a bit small. Let's actually go with 20 to 30. That was maybe a bit too big. How does it look in here? Actually, 10 or 15 to 20. Let's go like this. And let's also scale the size down, the sprite size towards the end. This way, they don't just pop out of existence. They both fade out through the color and the size. However, let's also add some noise. Let's go with a curl noise. Let's go with 200 this way. Yeah, this looks more like a rocket trail. Alright, let's change the color as well. Let's go with linear color curve. Alright. Should have done this in the beginning. Let's go with a linear color curve. Let's start with a darkish red. Let's go with a value of 10. And let's go in the middle with this one and let's let it fade out to a yellowish. Let's go with a value of 5. And towards the end, the opacity will be 0. So right now the problem is we still need to direct set the color. Alright. In order to be able to override it towards the end. Let's make this more orange. Let's actually lower the value to 2. And let's go with 5. This looks like a rocket trail to me. Yeah, this looks good. You can, of course, try around with different spawn rates and colors, whatever pleases you. Let's call this the rocket underscore trail. Alright, now we need an explosion. We can also turn off the sprite renderer because, well, rocket exists through the trail. We don't really need a rocket itself. This is just as a emitter. Let's change the bounds to fixed. And let's create a comment with this is the rocket. Alright, let's start with a minimal emitter. Now what we're going to do is not directly create the explosion itself. We are going to start with a kind of in-between emitter. We're going to call it the location underscore emitter. What this will do is give us the location of the rockets when their age ends. For this we need a death event, which we will create back in the rocket emitter, generate death event. This we will receive through a event handler, which will receive it through the received death event node. Alright, we need to do not handle incoming events. Where's the problem? Yeah. For a generate death event or any kind of generate event, we need persistent IDs. Alright, this problem is fixed. Now we see the death event in here. We choose this, spawn particles, and we want 1 particle per death event. Alright, what this will do is, you can see it, every time one of our rocket dies and fades out, it's going to spawn one of these location emitters. What this allows us to do is go into initialize particle, and the lifetime will be the pause in between rocket fading out and explosion. So let's give this some random range value between 0.2 and 0.5. Now you can see the particle either rather instantly disappears or stays a bit in the air. We don't really need this to be rendered. Again, let's set it to fixed bounds when it's turned off. So the last thing we need to do is we need a death event for this location emitter. So generate death event. All right, fix issue, and let's set a check mark at persistent IDs. All right, what we do with this death event now is create a minimal emitter and receive it. Again, create an event handler and a receive death event. In the event handler, choose the last one, the location emitter, death event, spawn particles. Now we want to crank it up a bit. We want a spawn number of, let's say, 100. This will be the amount of particles in our expanding ball, expanding sphere. All right, let's create the sphere. Shape location. Important is that it happens after the receiving of the death event. This works like a stack from the top. It's going to go through this, and then it's going to receive the death event, and then the shape location. All right. So let's set it to uniform. Let's make it for the to see it better. Give it a radius of 500. So now every time our location emitter dies, we spawn a sphere with a uniform distribution of our particles. All right. The problem now I encountered is if I just add a velocity and choose from point, let's give it a 2000. Oh, it's going to be too fast, but let's just take this real quick. Nothing happens. Why is that? Well, first of all, we need a solve velocity forces. But what happens now is it just flies away from the simulation position, which is the world position of the Niagara system. We don't want this. So we need some kind of position from the death event. You could say, oh, the shape location is using stack context position. This seems to be working. So let's just take this stack context position. Well, now this happens. The problem is stack context works like this, as far as I can imagine, and seems logical to me. It receives the death event location, the position. It applies it to its particle. Then it uses this as the origin of our shape location. But this shape location, or rather the event handler, spawns 100 new particles. And these 100 new particles, every single one of them gets its own position. And this will be overwritten. So if we add a velocity now, it's going to be to each singular particle. And every single particle has its own position. So it's taking the position from every particle itself. So we need to create our own position. We need to save the position right after it happens. So let's set a new, let's go with parameter. Set new or existing parameter directly. Move it after the received death event. Let's create a position value. Let's call it our death event underscore position. And change the simulation event to the stack context position. So, as you remember, it worked out at the shape location. So we just take it and save it right before that. We can keep the shape stack context in the shape location, but now in the add velocity, we call our death event position. What this does now is it's going to use the position we set earlier and use this as an origin for the velocity. So let's move this up so that we only see the explosions happening. This already looks right to me. The velocity seems right. Now our particles are living way too long. Let's put this to a value of 1.5. 1 and add some drag and some gravity to the particles, but minus 980 will be too much. They're just going to be falling down. We want them to slowly just fall a bit down or glide a bit down. All right. Now they're just disappearing, so we need to fade them out again. Scale color and take the alpha, float from curve, and let's give it a bit more smooth approach. Take the last angle. All right, don't forget to save. Okay, now it's saved. And let's also scale the sprite size. For this, you need to initialize the size in here first. Sprite size mode uniform. Let's go random uniform. Let's make them, I don't know, 30 to 50. That looks alright to me. Maybe a bit bigger even. 40 to 50. Let's see how this looks. Oh, okay, we were just very far away. Remember to take reference in the viewport as well, not only in the small window in here, in the preview. So let's keep it at 30 to 50. That looks alright to me. Now we can scale it down towards the end. Let's actually go with this template. Alright. Now, another benefit from using the location emitter is instead of putting or initializing the color in here, which will have its own kind of problem. Let's simulate this real quick. Random range. Let's go with blue and red real quick for demonstration purposes. Every single particle will have its own color. I don't know if you can set the color for the whole explosion and randomize it throughout the explosion so that every explosion has a different color, but all the particles in one explosion are the same. If you can set this up in one emitter, the way I did it was to leave this out and initialize the color in the location emitter. Let's go with direct set and random range linear color. Oh, excuse me. And with select linear color from array. Let's go with random. Let's make it 3 colors. Let's go with a teal. Let's crank the value up. Let's go with a red. Crank the value up again so that it shines bright. And let's go with a green value up again. So what we can do now is go in the event handler and the receive death event and apply the color. What this does is take the color from our location emitter and apply it to one entire sphere. You can of course change the color up with whatever colors you like and go with as many as you want. Let's maybe leave it alive a bit longer. Oh, let's not do that, but let's make it a random range value between 1 and 1.2. 1.2. So, next thing we need is to call this our explosion. And let's add a trail to these single particles. Save again. Again, you can either create a sprite trail, the way we did with the fireworks trail, or you can go with the ribbon renderer, which we'll be doing right now. Let's create a ribbon renderer, and we need a location event this time. So let's generate us a location event. Go into properties, persistent ID. Add an event handler on the recently created ribbon renderer, receive the location event, and voila, we already should see, oh, we of course also still need to select it, spawn particle, and let's have 1 ribbon per particle. Alright, as you can see, let's change the background. Yeah, now you can see it. And we want these to be a bit wider, so let's go into ribbon width attribute, direct set, leave it at 5, go into particle update, scale. Important, don't take the scale beam width, we want the scale ribbon width. Let's go with a float from curve. And let's zoom in. Now we can go back into the initialized particle. Oh yeah, lower the lifetime. Let's put it to 0.5. Let's look at it like this. Go into initialized particle and change the ribbon width to something that looks alright. Change down here so that we only see the explosion. 20 looks alright to me. Now let's randomize this again. Let's go between 18 and 23. Keep the lifetime. Let's randomize this as well. 2 to 0.5. And let's apply the color through the receive location event. Color apply. And let's also scale the color. Let's add a float from curve to the alpha and let it gradually scale out towards the end. And our trail is complete. Let's save again. Now let's create the blueprint. First of all, let's call this the explosion. For the blueprint to work, we need 2 user parameters in here. For this to work, we need 2 user parameters. One float, which will be our explosion trail, question mark, and our spawn count, which will be an integer. Spawn count. Spawn count, we're going to put in our spawn rate. However, we're going to change this up into a spawn burst instantaneous because we want to adjust the explosion trail with every iteration of the fireworks. Either it's going to spawn a burst with explosion trail or without explosion trail. Alright, let's deactivate our spawn trail and put the spawn count into the spawn count. Right now it's 0, let's put it to 1 so that we at least see 1 in here. The explosion trail basically is an integer as well, we only need the 0 to 1. But in the location event, the event probability is a float, and I thought it might give us a little bit of performance if we keep it a float and change it up in the blueprint instead of creating a float from integer every single particle. So let's create a new blueprint. Blueprint class, actor, bp underscore fireworks underscore tutorial. Let's go in here. Let's go into the event graph. We only need the event play. Let's spawn a system at location. Let's get the world location. Put it into location. Alright. This will be our fireworks tutorial. Let's change our variables, the one we just set. We need the set variable. We need a float and set variable for an integer. The float will be, let's take a look, will be the explosion trail. So we need a random integer in range, 0 to 1. And this is going to convert it into the float. Let's copy paste this. And this will be the spawn count. I will randomize it a bit. Just set it in here. We will have 1 to 5 rockets each iteration, each spawn circle. Now we need the exact names we have here. You can either go into rename and copy paste them. Spawn count will be our spawn count. And I've created a by string accidentally. We need the set Niagara variable here. Set Niagara variable float without a string. Let's call this the explosion trail question mark. Let's take the return value from our spawn system. Put the value in here. Alright. Now let's compile again. No more errors. So let's remove our Niagara emitter and let's put our blueprint into the world. Let's see what happens now. We spawned 2 rockets, 2 rockets, 2 rockets. Problem is, it's 2 rockets every time. What's important is we need to go into our rocket emitter, go under emitter update and put it in once. We want it to trigger once. Exactly. Because what we can do now is save again and add a delay towards the end of our blueprint. Promote a variable. This is going to be our delay. Make this public so that we can edit it in the blueprint in the world. And let's create a do n. Do n, here it is. And we want the n to be exposed as well. This will be the amount of times, or the waves, the iterations we will trigger. Let's put this towards the beginning. This will go in here as well. The exit will go in here. And so. Now we can go back into our world, into our viewport. Now you should see the, oh, my bad. Make it public as well, the amount. And now you can see the delay, which we can put to 1. The amount, which we can put to 5. We can trigger it. 1, 2, 3, 4, 5. And the last one had the explosion trails within. We can play around with this, like I showed you in the beginning of the video. 2, 20. Oh, well, after ending our simulation, 2 and 20. And as you can see, it chooses randomly each time if it wants a explosion trail or not. Now, to a problem I've encountered with this is the ribbons somehow seem to cause problems when your GPU usage goes up. For example, if I maybe can simulate this, I'm gonna tap out real quick and tap back in with these. This, now you could see it. It causes some weird glitch happening. I haven't found any solution to this yet. It seems to be connected to the GPU usage or the RAM usage. If you have any solution to this, please let me know in the comments. And there's another problem, which interestingly enough did not happen with the one we just made, but did happen with the blueprint I showcased in the beginning. With this, let's put the amount to 5, 2, 10, maybe we can see it. Sometimes it triggers the explosion 2 times. I found the cause to be connected to 2 things. To the spawn burst instantaneous and to the spawn rate connected with the location emitter I built in. The last particle spawned will always, I don't know if it happens always, but seems to be always, spawn or create 2 death events, which will cause the location emitter to spawn 2 particles instead of 1. There you can see it. It caused 2 particles. Now the problem with the spawn burst instantaneous is this will happen every time in a cycle. There's going to be a last particle. Unlike if we use a spawn rate, then there will only be 1 last particle spawned, which will basically never happen, or it will maybe happen once or twice, but you won't realize it, won't see it. Unlike the spawn burst instantaneous, which will happen every cycle. Every time one gets spawned, one will trigger twice, one here. Oh, no, it didn't happen. Here it happened again. That happened again. I did not deem this to be a bad issue because, well, it looks even better in my opinion, because it spawns 2 of the explosions, but just adds to the effect itself. During editing, I also noticed a few things I'm unhappy with, so I will go over these and create a new fireworks effect, a more advanced one, and I will post another YouTube video on how to make the new one as well. I hope you enjoyed the tutorial. I hope you learned something, and let me know if you have any suggestions what to do next, or what else effect you would like to see. I can't promise I can recreate it, but I will give my best and let you know. And I'm happy to receive any kind of feedback, as this is the first video I've created. So please let me know in the comments if you have any things I can do better. Let me know. Have a nice day. Goodbye.